Hi, this is a quick lesson on evaluating expressions. So these letters that we see are actually called variables. And we need variables. Right now it seems like, why are we throwing in letters? This is so weird. But later on in mathematics, we need variables so that we can model functions and use them to make predictions. Or to model data or to notice patterns or whatever. So to evaluate an expression, we substitute the numbers in place of the variables. That's it. And then you just simplify. So it's very simple. It's not scary at all. When I say substitute, that means, like, for example, if you think about a sport like football or something, when the quarterback that's playing gets injured, what happens? Do they bring in a new quarterback and that quarterback is now playing? Or do both quarterbacks play? One of them plays. So when you substitute something in for the other, you take the first one out and you bring a new one in. So let's just take a look here. First example I have is x squared minus 3x plus 4, where x equals -2. So this indicates that in place of x, I'm substituting -2. So everywhere there's an x, I'm taking x out and I'm substituting in -2. And a good habit for this is to put the -2 in parentheses wherever you substitute. I'm actually going to do a different color here so that you can see what I'm doing. So I'm putting the substitution in purple and then the original, whoops, in blue. And you can see that in place of x went -2. I put it in parentheses just to show that I'm substituting it in. And now we just have a normal algebraic expression that we can simplify using order of operations. So the first thing that you need to do in order of operations is parentheses, exponents, and multiplication. So I'm going to go through. I do have an exponent here. -2 squared means -2 times -2, which is +4. So be very careful with the negative there. That's one of the main reasons I want you to put it in parentheses, because it does matter. We're squaring -2. And then I have multiplication here. -3 times -2 is +6, and then a +4 at the end. And then we just have addition. 10 plus 4 is 14. So this expression, evaluated at -2, is 14. You might see this. I'm just going to do a little side note here. You might see this like this. That's a function. F of x is a function. And then you might see it f of -2. That's where you're subbing in -2. And we already found that out. F of -2 is 14. So this is basically where this is leading. There's lots of applications of this, but this is one of the most common places that you're going to see is evaluating functions. And so this is a function. And if we evaluate the function at -2, we get 14. So if you were to graph this function, this point, whoops, sorry, would be -2, 14. That's not specifically in this course, but I just wanted to kind of show you where this is leading and how it's useful. So maybe you will see this in the future. If you're going to take algebra, you're going to see this in the future for sure. Okay, let's look at the next one. It's very similar. If you want to pause it and try it on your own and then come back, that would be a good idea. That's a good way to practice. So I'm assuming you paused it. If you paused it, you should now have -1 to the third plus 2 times -1 squared minus 5 times -1 plus 1. So I substituted -1 here, here, and here. Everywhere there was an x. -1 to the third means -1 times -1 times -1, which is -1. And then be careful right here. We have 2 times -1 squared. You have to do the exponent first. This squared is attached to the -1, so we need to deal with it. -1 squared is +1. So now we have multiplication, multiplication, and then we just have addition. 1, 6. So this function evaluated at -1 is 6. So if we were to look at a graph or a table, this point would be -1, 6. Isn't that neat? Pretty simple, right? So I'm going kind of fast on the order of operations because I've already covered it. If you're struggling with that, you might go back and watch my order of operations video. But basically, long story short, I'm kind of following PEMDAS. I don't totally agree with using PEMDAS, but it does work most of the time. So basically in PEMDAS, you have to do parentheses, exponents, and multiplication first. Then you can add and subtract as your last step. So I am doing that. All right, so in this case, we have 2 variables, and I'm going to be substituting 3 in place of x and -1 in place of y. So everywhere there's an x is 3. Everywhere there's a y is -1. And I'm doing different colors just to kind of show the substitution. I'm trying to be real careful that I'm copying everything down correctly because, whoops, I did the wrong color. You don't want to make little tiny mistakes. I'm just going to check and make sure that I've typed it all in correctly. -6 times x, which is 3, times y, which is -1 squared, plus 9 times x, which is 3 squared, minus 4 times 3 squared times -1. So when these are side by side like that, it means multiplication. So x squared y means x squared times y, or xy squared means x times y squared. So that's why I just put everything in parentheses, because when parentheses are side by side like this, it means multiplication. So I like the parentheses. Which means that within this term or addend, we have exponents, and I need to deal with the exponents before I can multiply. This is not 3 times -1. It's 3 times -1 squared. So I need to simplify that first before I can move on, which is +1. This is 9. This is 9. So I actually went through and I did all the exponents in one step. If you want to do one at a time and work your way down, that's totally fine. Remember, this means -1 times -1, 3 times 3, 3 times 3. So that's where I got those. And then now with my terms, this is a term, this is a term, and this is a term. I have multiplication in each term. So that's going to be -18 plus 81. Whoops. I don't know why it's doing that. I think because my battery on my pencil's low. Plus 36. And then we just add. So when you add those, you should get 99. Pretty easy, right? Okay, next one. Go ahead and pause it and try it. When you come back, you should get 0 squared minus 4 over 0 plus 2. 0 squared is just 0. 0 minus 4 is negative 4. 0 plus 2, and then we just simplify. That's it. So simple, right? Okay, so this is one of those rare examples where PEMDAS doesn't work. You're supposed to do parentheses, exponents, division. We can't really divide before we do these, so that's just one of those rare cases. But you can see how it works out, and it was fine. Okay. Now you try again, pause it, work on it, come back. You should get that when you substitute it in. Negative 3 squared, careful here, is positive 9 because negative times negative makes a positive. And then same thing here, this is a positive 27 and a positive 18. And then when you add those, you get 36 plus 18, which is 54. Easy peasy. Last one. Ooh, we have 3 variables. Pause it, work on it, come back. Okay, so once you finish, you should get something like this. You end up with 22 over 43, which does not reduce. So that would be your answer. There was one more thing, not in this lesson, but in the next one. I did cover these two in my simplifying algebraic expressions video, so I'm not going to show those again. There was another one in here. These are just word problems for evaluating expressions, so you can kind of see a little bit of the application. I'll just show one of these so you can kind of see. Karen walks dogs for a flat fee of $10 plus $5 extra per dog. The function can be modeled by this equation. So she's walking the dogs, and she makes $10 plus $5 per dog. How much money would she earn if she walked 5 dogs? So we need to substitute. It says 5 dogs, and then it's $5 extra per dog. So D stands for the number of dogs. And we have W equals 10 plus $5 per dog. So we get 10 plus 25, which means she would make $35 if she walked 5 dogs. So that's all you do. If it's a word problem, you just plug it right in to the correct variable. And then that's just another example. We've got Alexis owns a school supply store and charges $5 for a pack of pencils, $2 for a pack of erasers, $10 for a ream of paper. She'll cut the price in half the day before school starts. The function can be modeled by this equation. So we can see it's $5 per pencil, $2 per eraser, $10 per ream of paper. She's cutting it in half if it's the day before school starts. So this person goes in the day before school starts. She buys, or the student buys, 3 packs of pencils. So 3 goes in for P, 1 pack of erasers, and 5 reams of paper. So you just have to plug them into the correct variables, the corresponding variables. So $5 for pencils, $2 for erasers, $10 for paper, and then we're cutting it in half since it's the day before school starts. So you should get 15 plus 2 plus 50, cut it in half, 17 plus 50, cut it in half, and so on. So you would get a decimal here, which makes sense because we're talking about money. Oops, ran out of room. Sorry, there you go. And I believe that is, yep, 33.5. So $33.50. That is all I have for this lesson. I hope you enjoyed it. If you have any questions, let me know and I would be happy to help.